All right, wonderful fourth grade math teachers, welcome back to another Prep Talk video. In this video, we're going to be talking about interpreting remainders and problem solving using division. So I hope you're ready. Get excited. This is going to be great. We're really excited to help you out with this particular unit as you get ready to finish up division of whole numbers in fourth grade. So here we go. The learning objectives we'll focus on in this video include interpreting the remainder using manipulatives and the standard algorithm when dividing, and solving problems that involve division using both strip diagrams and equations to represent the problem, and then having students use two different strategies in order to arrive at the answer. We want students to show proficiency in two different strategies, but of course, most students eventually will settle on the strategy that they like the best. But as we continue to work our way through division and have students arrive at mastery with this skill, we want them practicing two different ways, whether it be partial quotients or the area model, or definitely the standard algorithm. We want them to be able to check their answer using a different strategy. As we take a real quick look at the TEKS that we'll cover in this video, you'll notice that the readiness standards have been tested a fair number of times in the past on STAR, and that 4H includes that phrase, interpreting remainders. And what we're going to see as we look at released questions is that's really a big emphasis in these STAR questions. And so students are going to want to be able to interpret that remainder. So as we get into interpreting remainders and what they mean in real-world context, we want to present students with several different problems and have them discuss, do we need to increase the quotient in a particular case, or is it okay to ignore the remainder? And so if you look in your math and practice book on page 127 through 129, there will be a great script for you to follow to have your students begin this conversation. And so as we look at the problem on the left, there are 34 students in the fourth grade. You're going on a field trip, and each van holds 5 students. Well, as the students do that division, they're going to notice that they end up with a remainder of 4. And so the question becomes, what do we do with those remaining students? Is it okay for us just to get 6 vans and leave the other 4 students that are left over behind on this field trip? Or should we increase the quotient to 7 vans so that we can include those 4 that were left over? And so you might ask them, would you want to be one of those 4 extra students that gets left behind if we don't get that extra van? And most of them are probably going to say, no, I don't want to be one of those 4 extra students. So in that case, we definitely need to increase the quotient so that we can include all of the 34 students in the fourth grade class. Then compare and contrast that with the other problem that Sarah is making necklaces. Each of those necklaces requires 9 beads, and if Sarah has 137 beads, by the way, I'm not sure why Sarah lost the H on the end of her name in the second sentence, but you can go ahead and correct that on my slides. If Sarah has 137 beads, how many necklaces can she make? And so as the students do the division for that particular problem, and they end up with 15 and a remainder of 2, well, that remainder of 2 doesn't really help me because I can't make a complete necklace with just 2 beads. I have to have a whole 9 beads in order to make another necklace. And so in this particular case, we would ignore the remainder and say that we would be able to make 15 necklaces from the 137 available beads. And so there is a great card sort available in the curriculum resources that you can have students work through so that they understand the difference of when we need to increase the quotient and when we are going to be able to ignore the remainder. As we're going to see in this released question, the other thing that students need to be able to do, other than recognizing do I increase the quotient or ignore the remainder, is actually understand what the remainder represents in the context of a real-world problem. For example, here, Valerie had a jug that contained 128 fluid ounces of salsa to put into bowls at a restaurant. She filled each bowl with 6 fluid ounces of salsa until there was not enough salsa left in the jug to completely fill another bowl. How many fluid ounces of salsa were left in the jug? One thing you'll notice about this question is that nowhere does it explicitly say to divide, and so that is always the first step, is having students close their eyes, immerse themselves into the story of the problem, read it for comprehension, and understand that we're going to be dividing 128 by 6 in this particular question. Students can do this with whichever method that they want to. I'm just going to model the standard algorithm really quickly here. 6 will go into 1 0 times. 0 times 6 is 0. 1 minus 0 is 1. Bring down the next place value. 6 then goes into 12 twice for a total of 12. And of course, we would have students create a top-bottom chart here as we're doing this. And so when we do this subtraction, we're going to end up with 0 and bring down the next place value, which would be 8. 6 will go into 8 one time, and that will give us 6. 8 minus 6 will give us 2. And so since we are out of room up here, we know that we are done. And so what we end up with is a quotient of 21 and a remainder of 2. And you'll notice that both 21 and 2 are answers in this particular question. And so going back to the question, how many fluid ounces of salsa were left in the jug? Well, the 21, the quotient, that represents the number of bowls that we're going to be able to completely fill up with salsa. The 2 represents how many fluid ounces of salsa were left over in the jug. And so having students discuss this, talk about this, is going to be really important so that they don't choose the 21, which of course was the most popular wrong answer when this question was given, and that instead of choosing G, they actually picked the correct answer, which is J. This released question is a very important example of when students will need to know that they have to increase the quotient. I just want to point out before we get going how close each of these answer choices are to one another. As we look here, Eric has 158 action figures to put in display cases. Each of those display cases can hold 8 action figures. How many cases does Eric need to hold all of his action figures? And so that means we don't want any to be left out of a display case. Even if we can't fill up a full display case with those 158, we want to make sure that all of them get into a display case. And so this would be a scenario where students would need to increase the quotient in order to hold all of the action figures. And so as we begin the division, whichever method we want to use here is going to be just great. Let's say that we want to use partial quotients in this case, and so we might start by multiplying that 8, let's say, by 10. And so 10 times 8 would give us 80. If we subtract off that 80, we're going to be left with 78. So I see that I can't do another 10, but I could certainly do another 5. And so 5 times 8 is going to give me 40. And if I subtract that off, I'm going to be left with 38. How many times will 8 go into 38? That would be 4 more. So 4 times 8 would get me the next number, which would be 32. And that would give me 6 left over. And so adding up those partial quotients would give me 19. But with 19 display cases, I'm still going to have 6 action figures just left out in the cold. And we don't want any to be left out in the cold. We want cases that are going to hold all of those action figures. And so this is where we would increase that quotient up to 20 so that we would be able to hold all of the action figures. This is a high-level question. Lots going on here, lots to discuss, and so you'll want to make sure that you chunk this and scaffold it for your students so that they understand the rationale behind each thing that we're doing in order to solve this problem. This question should look a little familiar because it's very similar to that question with Sarah earlier about the beads and the necklaces. This time we're though talking about bracelets. And so Kareem will use beads to make bracelets. He has 475. He needs to use 9 beads for each bracelet, and we want to know the greatest number of bracelets that Kareem can make with those 475 beads. And so, if you've worked through that card sort and talked about when do we need to increase the quotient versus ignore the remainder, hopefully students are able to determine here that we will be able to ignore the remainder. And so again, recognizing first that this is a division problem, and so 9 into 475. If we wanted to use partial quotients again, then we realize we might be able to multiply 9 by, let's say, 50, and 9 times 50 would give us 450. That would be a little aggressive here, which is okay. As students get more comfortable with partial quotients, hopefully they are starting to get a little more aggressive in shaving off that quotient. And so now 9 into 25 is going to go 2 times. And so 9 times 2 will give us 18 with 7 left over. And so we know that we're not going to be able to make an entire bracelet with those 7 beads that are left over. And so the total number of complete bracelets that we'll be able to make is going to be 50 plus 2 when we add together our partial quotients, which of course will be 52 and letter A. You'll notice that 53 is an answer choice, and that's for the student that believes that we take that remainder of 7 and use that to increase the quotient. But of course, that's not what we're doing here because of the parameters of the problem. And so this is going to be really important that you're allowing students to discuss the differences between the two problems. And you might even put both problems up on the board and have them talk about the differences between each one. Why would we increase the quotient here versus ignore the remainder here, and have them really talk through the differences in the two problems. As we move into TEK 4.5a and look at strip diagrams, let's look at the following released question. A business earned $96 for one job and $78 for a second job. The money was divided equally among the 3 partners who own the business. Which strip diagram represents M, which is the amount of money that each partner received? And so what we notice from the first sentence is that we're going to have a total. 96 on the one hand plus 78 on the other hand. And so we should see those two numbers conjoined together to make a total. And we see that in letter F and in letter J. We do not see that in H, which doesn't say anything about the $78 for the second job. And G says just a little too much. It says 78 times 3. And so that is for the student that believes that with the 3, we will be multiplying in order to get a total. And so we can eliminate G and H. Then, as we look at the second sentence, we want to divide that total equally among the 3 partners who own the business. And so the only strip diagram that represents a division of that total into 3 equal groups, of course, would be letter F. Now, one strategy that can really be powerful for students when they work these types of problems is a lead forward strategy called fixer upper. And this is where students take each of the other answer choices and think about how the problem would have to change in order for that answer choice to be correct. You can look up this fixer upper strategy by just Googling lead forward fixer upper strategy. And we can also put this in the lesson resources for you to look at as well. But students would basically look at one of the remaining answer choices. So for example, as we talked about for letter G, why would letter G be the correct answer? What would we have to change about the scenario in the problem in order for G to be correct? And hopefully students would notice that 78 and 96 were being multiplied by 3, and so we would have to figure out some way for the problem to involve multiplication instead of division in order to get one total. Or maybe letter J, which is an even simpler problem where we just have a business earning $78 for one job and $96 for another job, and we want to figure out what the total is for their earnings for those two jobs. Whatever the scenario is, this forces students to really analyze, based on a given strip diagram, what would a problem have to say in order for that strip diagram to represent the problem. As we look at the next released item, we'll introduce another lead forward strategy called Musical Mix Freeze Group. This makes things fun and engaging for students because you'll be playing music while students mix around the room. You stop the music and say freeze, and then say group, and students get a partner or a group of three that are close to them. You then present the question on the board, and students will work with their partners to answer that question. Then you are able to see and hear the students thinking and clarify or verify as appropriate. We have the instructions for this strategy listed in our lesson resources, so please feel free to look at that if you'd like to utilize this strategy. As we look at this question, we see that Sabra read a total of 185 pages in 3 days. We see that all four answer choices have things broken up into groups of 3, so that's good, but only 2 of the answer choices have the total as being 185. Letter A and letter D. Letter B and C are looking for the total, and that's not what we're doing in this particular problem. Then we keep reading. The first bullet point says that on the first day, she read 85 pages, and on the second and third days, she read the same number of pages. And we want to know a way to find P, the number of pages that Sabra read on the third day. And so the differences between A and D, as you'll notice, is that this one has the 85 in place of the first day, and letter A does not. And so letter A would be the incorrect answer, which would leave us with letter D being correct. And again, we want students to be justifying their answers, not just accepting their answers at face value, but having them dig deep into the justification and saying more about how they arrived at the correct answer. That way you, as the teacher, can verify or correct as necessary. As we finish up this video, let's talk about one last lead forward strategy that comes from Nancy Crouch. This is a great problem-solving strategy to have students really immerse themselves into a problem and think about the problem through several different lenses. And so this problem-solving mat is available to you in our lesson resources. You'll see that it's broken up into 6 squares, and in those 6 squares, students are going to see, first of all, a word problem, a real-world problem that they have to solve. In box number 1, they're going to draw a picture that represents that problem, and hopefully they will be drawing a strip diagram in order to represent that problem. In the second box, they'll be writing 2 equations to represent that problem, and in box number 3, they will be estimating the solution to their problem. In boxes 4 and 5, they will actually be solving the problem 2 different ways. And in box 6, they will be looking back at both their estimation and their solution from boxes 4 and 5 to see if their estimation and their answer are compatible with one another. Now, as students begin to do this, the way that we've set this up is that we already have each of these 6 boxes done for them, and so all they have to do the first iteration is to sort these different cards into where they would go on the place mat. And so obviously the picture for this particular question would be here. That would go in box 1 on their problem solving mat. And so they're having to see, does that strip diagram actually match up with the word problem that's given on this particular mat? In box number 2, they're going to have to write the equation and then another equation for this particular problem. And you'll see that there are 2 cards that have equations. And so they're going to have to determine, is this my estimation Or is this my estimation? Are these the actual equations that go with this problem? Or are these the actual equations that go with this problem? And what they'll come to recognize as they work in their groups is that this is the representation of the actual equations and this is the estimation. Then for boxes 4 and 5, those will be two different ways to solve the problem. And so this could go in box 4, this could go in box 5. Obviously, those could be interchangeable, as the one that I've labeled number 4 is the standard algorithm, and number 5 is partial quotients or using the area model. And so as students do this the first time, you have already given them everything that they need and they're just analyzing. The way to gradually release students through this, and this is modeled in our lesson resources, is to have students then take a second problem and do each of these things themselves. Draw a picture or a strip diagram, write the equations that are represented by the problem, estimate the solution, solve the problem two different ways, and then look back at boxes 4 and 5 along with number 3 to see if that estimation actually matches up with the answer that you got. And so you'll notice you're not really working a lot of problems. You're just taking one problem and dissecting it and scaffolding it and really unpacking it and diving into it to have students understand how to draw the strip diagram, how to write the equations, how to estimate their solution, and then how to solve the problem two different ways. And then, as always, we want students to look back and see, did their estimation really match up with the answer that they got in these two boxes? And so the discussion that you should hear during this time should be really rich. This will allow you to maneuver throughout the room and focus on the students who need the most help. And you should be really enjoying this time because students are really unpacking and talking with one another deeply about these word problems. If you guys have any questions about anything that was discussed in this video, as always, you can reach out to the Teaching and Learning Department, either myself, Ryan Castle, at rcastle@mesquiteisd.org, or our amazing 3 through 5 facilitator, Sherry Height. She is slheight@mesquiteisd.org. And as always, before you go, please fill out our survey so that we can know that you watched the video. You are actually able to ask questions if you have one through that feedback process as well. So either using the QR code on the left or the link that is provided on the screen. Thank you so much for watching. Good luck as you finish up your division unit, and please feel free to reach out to us if you have any questions.